Okay, question number 18, Pathfinder, Newton's laws of motion, MCQ. Three identical balls A, B and C, each of mass m, are connected by three identical springs. So when placed on a frictionless horizontal floor, occupy corners of an equilateral triangle as shown in the figure. So in the figure, see, there are three balls. They are connected via springs, and first it is placed on a table and it's forming an equilateral triangle. Now what happens? See, this assembly is suspended by attaching the ball A to the ceiling with the help of a light thread. Now this ball A is attached to a thread, and now the whole system is placed, it is hung vertically. Okay, so it will no more be an equilateral triangle now. What can you predict regarding the acceleration of the balls immediately after the thread is cut? Now when the thread which is connected to the ball A, when it is cut, we have to find the acceleration of every ball just after the cut is made. A beautiful one-liner question. Let's see how to solve it. Ball A is hung via a string. The whole system has a mass of 3 mg, and the tension in this thread will be obviously 3 mg to balance the system. When the thread is cut, the tension becomes 0. The whole system starts to fall, and let the accelerations be AA, AB and AC, and see what happens. Now if we write the equation for the whole system, the external force 3 mg is equal to the summation of MA of every ball, say an equation like this. These three balls, even if they are accelerating, their velocity and displacement are still 0. Just after the cut is made, they may accelerate, but they will not acquire velocity, they will not be displaced by any amount, because they haven't got any time to do that. Velocity requires time to build up. Similarly, displacement, it requires time, because even if you know the basic formula, ut plus half at square, displacement ut plus half at square, so it requires time, it requires acceleration and time. Velocity is equal to u plus at. Even if u is 0, it is a into t. So velocity requires time to build up if initial velocity is 0. So velocity and acceleration, they require time to change. Acceleration does not require any time to change. As soon as the force changes, acceleration changes. Velocity requires time to change. Similarly, displacement requires time. So these three balls, they will acquire acceleration, but they will not acquire any velocity because they haven't got time for that. And they will not be displaced just after the cut is made. They will be displaced, no doubt, but after some time. They will acquire velocity, no doubt, but after some time. But that time is not given to these balls, because the question is find the accelerations of the balls just after the cut is made. So the lengths of springs will not change. This is the main thing. The spring will be in the same lengths as they were just before the cut. If the lengths of springs do not change, the spring force will not change, because the spring force directly depends on the length of a spring. So suppose we consider ball B. So ball B, there are three forces acting on ball B. It's weight and two spring forces, and nothing is changing. See, weight is a constant, of course. This spring force will not change because the length of spring cannot change. Similarly, this spring force will not change because the length of this spring as well cannot change. These springs cannot change their lengths unless these balls A, B and C move. And these balls require time to move, and we haven't given time yet. Okay, so ball B is still experiencing the old forces. Nothing changes, so ball B will have 0 acceleration. Similarly, ball C will have 0 acceleration. So put the acceleration of ball B and ball C as 0 in it. Now we have acceleration of A equal to 3g. So ball A will accelerate 3g. For ball A, force has changed suddenly because earlier there was tension, and as soon as that string is cut, tension becomes suddenly 0. So it is changing, force is suddenly changing for ball A. So that's why ball A has got acceleration of 3g. Okay.